So hi everybody, my name is Mohammad. I'm a senior research engineer at a company called Lab Research, which is based in Technopark in Trivandrum. Before this, I was at Ernst & Young, Trivandrum, and then I used to be part of the AI team. We done a bunch of interesting stuff. And this workshop, I just wanted to know first off, why are you guys here? Is there something that brought you here? Is there some sort of experiment or some sort of a robot or an app or something that kind of inspired you to come to this workshop? Or is there a lot of news articles that are floating around that brought you here? Feel free to type in your messages. I'll just take a few of these responses and then we'll move on, right? You can also unmute yourself and then give me an answer. Have you used FaceApp? Really want to know more about AI? Good. What all subjects do we need to study AI? I will get to that. AI is interesting. AI and self-driving cars, good. Okay, let me address your worries first, okay? What all subjects do we need to study in AI? First off, I want you to know that I was not good at math. And then people are scared because they think a lot of calculus is required. I'm going to show you a lot of demos today, a lot of things that you can do today, and none of it is going to need hardcore programming or math, if that is what is scaring you. Want to know the difference between, consequences in the future with AI, Python, deep learning, interested in knowing the future impact. Awesome, good. I came across a replica AI friend. Okay. Coincidentally, this is also the same reason why I got into AI. Is it possible to implement some AI and ML in web development? Yes. Search for GPT-3 React app, and then you'll see an AI actually write the code for an AI front-end app. All right, good. I think we have a lot of interesting stuff. Image processing. You'll see a lot of image processing today. So I'll just get started. Thank you for all of your answers. I think we'll proceed now. All right, so today, before I get started, stop me if I speak too fast. This is something that all of my students tell me. Sometimes I get too excited and then started blabbering off, but if at any time you feel I'm speaking too fast, feel free to interrupt. All right, so let's start with this. Have you guys seen this? So anytime you upload a photo to Facebook, watch what happens. So someone's uploading a photo and then here's the thumbnail and it automatically picks up the person in that picture, right? And Facebook is doing this with AI, right? Here's another question. Have you guys played this game? It's called Pac-Man. I'm not sure if all of you have played this game, so I will show it to you myself. So you search for Pac-Man, and Google automatically has this Pac-Man game that you can play. It's a little bit loud, but so I am the yellow guy at the bottom. All right, so that's the game. Just a reminder if you guys have forgot about it. So we talked about AI in Facebook's image upload, right? Do you think there is any AI in this game? You may use the chat for your answers. It's a very old game, Pac-Man, yes. Think about what all things are there in this game and then give me a rough answer. Do you guys think there is any sort of AI, or assume that a human is playing just like I was playing now? And is there any AI? Yes or no? All right, someone just to identify enemies. No, not exactly, but people who are saying yes, yes. Good. All right. So we will come back to this. Someone said no. We will come back to this. All right. Player positioning. Very, very good answers. We will get back to this. All right. So this is another example where these two people, Will Ferrell and Chad Smith, these people are dressed as each other. So Will Ferrell is dressed up as Chad Smith, and Chad Smith is dressed up as Will Ferrell. Okay, and this is the Tonight Show, and basically it was difficult for the audience to tell which guy was which. But what you're seeing on screen now is actually a machine learning model that is able to label them correctly. And it's not getting them wrong even slightly. So it's like 80 to 90% confident all of the time. So that's the state of the art. Here's something. This is Google Translate. And then I'm sure you guys are familiar with this. I basically watch all my Hindi movies along with Google Translate. And basically the way is, like, for example, if you have 3 different languages, right? How do you train a system to actually translate between 2 different languages? The way is that what Google did was it took, it had a lot of access to a lot of books, and those books were translated into multiple languages. For example, you might have a version of the Bible in English as well as in Malayalam, in Hindi, and all sorts of stuff, right? And basically what they did was they took thousands of such books and their translations and then fed it into machine learning model. And then what it eventually learned was that it could translate given any language, from any language to any other language. For example, I would only give as input my one of the books that I would choose would be in English, and a translation would be in, let's say, Romanian. But eventually, even it learned to translate from Romanian to Hindi and from Hindi to French and all of that, even though there were no direct translations available. So that was pretty crazy. So I wanted to show you something, and then I wanted you guys to kind of point out all of the AI or machine learning systems that you see here. Okay. So what I'm going to do is I'm going to translate a phrase from English to Hindi, okay? But in the middle, there will be a lot of different machine learning systems involved, all right? So I want you to point out anything that you see as a machine learning model, and then let me know in the chat. So your task starts now, all right? All right, how many did you guys catch? Prediction. You guys can give, okay, instantaneous search prediction in Google. That's definitely the first one. So Ritik, you're right. Anything else? Search engine suggestions, translations. That's good. That's really good. That's 3. Rearranging what exactly? Sentiment analysis is not used here because it is not showing me my emotions. Translation is good, so that's 1. There are a couple of things that subject, word, object. Maybe it's using all of these internally, so that's also right. Searching the next exact words, language recognition, that's also right. Good one, Daniel. It's all right. Let's go. You guys are covering a lot of ground. I'm just kind of nervous that you might not get anything from my workshop. But let's see. All right, the first thing that I did, let me close this tab again and go over this again. So I opened up a new tab and said English to Hindi, and then that was automatically suggested to me, right? So if I continue typing, so this is called autocomplete, and that's actually the first AI system in the picture, right? Now what happens is I press enter, and Google is searching for certain things, but you know what, Google is usually it's supposed to give me a list of links to web pages, right? But here it kind of detected that I was trying to translate from English to Hindi, and it gave me this very convenient box up here, right? So that's somewhere, it's detecting what kind of task that I wanted it to do. For example, I could also type in stopwatch, and then it gives me a stopwatch, right? So this is also AI. It's kind of trying, it's not using exact words. If I say translate from English to Hindi, it'll also bring up this box, right? So it's kind of detecting the task. That's two. Third one is I typed in, hi, how are you? And it automatically detected that this is English. That's someone said that already. But also it's kind of showing me the same kind of autocomplete things that I did while I was searching, right? So that's another level of autocomplete. So that's 4. So then I click on this. It will translate what I wanted into Hindi. So that's neural machine translation. That's 5. And the last one thing that people always miss is this speaker icon, right? How is it converting all of my text to speech that I can hear? So that's also machine learning. So it kind of learns the same thing that we did with translation, but instead it takes text as input and lots of recordings of books and plays and stories and things like that, lots of audio that we have collected, and then kind of maps text to sound, and that's how text to speech works. So yeah, those are the 6 different things involved here. If you catch any more, let me know. And also, there was a person who said, subject, verb, object, and object. See how that works here. For example, so this is not a word-for-word translation. Like hi is not. Maybe you could say that hi is namaste. But look at this. How are you? Right? You is the last word in the sentence, and the most closest representation for you is up, right? But it does not occur at the end. It kind of puts it in the middle. So it kind of knows how to restructure your sentences also. So that's the thing about subject, object, and you don't have to know about it. I just wanted to kind of address it in case you guys are interested. Yeah, so that was a lot. All right, good. Don't worry. I see people who are saying that there is no knowledge. You have no knowledge in this field. That's why you guys are here, and that's why I am also here. So don't worry about that. All right. Let's kind of go to the next thing. Here's another system. Take a look at this robot. So this is a robot from Boston Dynamics. It's called Atlas. It's jumping up and down, and it's also doing things like somersaulting. And video is a little bit laggy, but I hope you guys could see that. Yeah, so this is what it looks like. So what do you guys think? Is this AI? Yes or no? And yes, AI, yes. Overwhelming number of people are saying yes. All right, cool. So let me tell you something. There's a difference between what people consider AI and what is known as robotics, right? And robotics does not always rely on AI. Perhaps there are a few systems in here that is kind of doing some things, but in general, in such a video, in such a robot, a lot of things are basic control systems. Like how do you balance it? You don't need a lot of data for that. You kind of learn how to do that with control systems. So yes, there might be a little bit of AI involved, but not as much as we might imagine. So that's another one. How many of you know this guy? If you're watching Hollywood films, you might recognize this person very quickly. So I'm gonna switch to my chat screen. AI means training. We will get to that. That's one of the questions. But AI, what is controlled by humans? That's right. But actually, Atlas was controlled. It was not doing its own thing. All right. Anybody can recognize this guy? Does he look familiar to one of the persons in Fast and the Furious? Okay, that kind of put in a lot of responses. Yes. Paul Walker, yes and no at the same time, and I will tell you why. This image of this person is not real. It's generated by a computer. So I'll show you how it goes. So basically, there is a data set called the Celeb 100, Celeb 1000. I'll show you how it is. So this is 1024 into 1024 images. So 1024 pixels horizontally and vertically. And these are some real actors, okay? And there's like tons of different actors in this data set. A data set is basically a collection of data. In this case, it's just images. All right, and these are the final images. This is what the model has created. So this is one. And we'll also see how these were generated, because it's kind of crazy, right? So what happened was, this is done by NVIDIA, the GPU company that you guys use to play your games. So it's called progressive growing, and what it means is the model starts generating very low quality images. So at the bottom left, you can see the number of pixels. So 32 by 32, 64 by 64, 128 by 128. Over time, it starts generating better and better looking images. So in this bottom center, you can see the number of, how many hours or days were spent in training. And that's basically how you get all of these images. It's almost real. So I actually pulled this off a couple of years ago from one of, I think it was last year or the year before that. But now it has advanced so much that you guys kind of know this. It's in your phone. It's called FaceApp. I don't know how many of you guys have tried this, but if you're male, try converting yourself into a female version, and that is what people generally stop at, right? But also try to convert that female version back to a male version and see if you get yourself, which you won't. And the reason that this guy looks like Paul Walker is because Paul Walker's photo was in the data set. So it's kind of learned certain features and it kind of put them together, and then you feel that this is Paul Walker. It's not Paul Walker's photo. It's generated. So let's go to this other website. Just in case you guys want to see more of this, you can go to thispersondoesnotexist.com. And then these are today's standards. So I told you that that other image was a couple of years ago. This is in December 2019. All right, and it looks so real, right? Like, look at the amount of detail on this guy's face. So if you want to see another picture, just refresh this, and then you will see another person. And you can see that it kind of generated this person very well, but also look at the sides and edges. Kind of tells you what the model kind of learned and what it did not learn. It kind of learned to ignore all of this. It thought this was all not necessary, and this was the important part. It looks really real. So it's generating all sorts of ethnicities, all sorts of ages, male, female, of all ages, different kind of clothing and all of that. And if people don't interest you, you can always go to this cat does not exist. And then we have versions with cats, much lower resolution, but all generated cats. These are not real cats. All right, so that's it about generations. So I want you to look at this other thing, and then again, let me know if this is AI or not. What do you think? So what did you guys think? Is that AI? All right, a lot of people. Awesome. A lot of people believe that this is robotics, 3D drawing, robotics and AI. Okay, good. So this is basically something from 5 or 6 years ago. I think it's a lot longer than 6 or 7 years ago. And this is basically robotics. It's using some sort of image processing called edge detection. There are much better ways to kind of create an outline of a picture given an image now. So I'll give you one more. So we didn't answer this. So this is not AI. There was no AI being used at all. And it was just robotics as well as some digital image processing. So what about this? This is a robot, and then you can see that it has a face. It's reacting to things that people are saying. You can talk to it. It can talk back, and depending on what you guys are talking to it, it will be happy or sad or angry, and then it can even tweet about you. What do you guys think? Is this AI or is it robotics? Awesome. Overwhelming number of people are saying it's AI, because that's good. You guys are recognizing components. I just want to make sure that you guys are good at that. It's definitely AI. And I can speak for these last 2 projects authoritatively, because this was me and my team back at EY where we built this robot. And let me also tell you something. It might seem very, very sophisticated, but I think this was one of the first 3D printed robots in Kerala. This happened about 5 years ago. We had one of the first 3D printing machines. And this face that you see here, it's actually not that complicated. It's a cell phone. It's a mobile phone that we put in there. And then we had a browser tab open at full screen. And it's processing all of this and then sending out messages to show you the emotion. So it's definitely, this is a touch screen that we mounted on a shell, and then that's what is giving you all of these emotions. It sounds very, very complicated. And this, on the top left, you will see my icon. So this is something that I have put up. So this is something that we built back in the day. So those are 2 things that I thought I would share and then kind of get your interest up as well. So today I wanted to show you, so I have very little time with you guys. I think I have already spent half an hour on the introduction. So Basically, I wanted you guys to know what is AI, what is machine learning, and what is deep learning. And I'll give you plenty of examples to wrap your head around it. It's going to be very, very visual, like the slide so far. So everything will have some sort of visual analogy or a demo associated with it. So there will be no map, there will be no code or very little code. And then I'll show you a lot of examples, right? So these are very confusing terms. People kind of throw it around and then substitute one for the other. And at some places you can do it, but basically this is where people should start, right? You don't know what is AI, what is machine learning, and what is deep learning. And then let's clear those terms up. So we'll start with artificial intelligence. And I want you to know that the reason that this workshop is called Introduction to Artificial Intelligence is because it's the all-encompassing part of this field. So artificial intelligence is the broadest thing that you can divide this domain into. And there are subsets of artificial intelligence, right? And we'll get to them. You will see it in the next picture. So just know that artificial intelligence is the big thing and everything else is a subset. So artificial intelligence is about making agents act rationally, right? And here's another question to you guys. Do you guys think artificial intelligence requires training or a lot of data? Yes, yes. All right, good. So let me also answer that question. The answer to that question is if somebody asks you, does artificial intelligence require training and lots of data? The answer is no. And I'll tell you why. I'll show you a bunch of examples also. All right, and to explain this, I'll show you how we are addressing this with search. Search not in terms of Google search, but search like this. You might have done this in your Calculika or your Badrima. So basically, let's say that I'm searching for a cake. Okay, the cake is in red on a very big space, and I'm starting out at the green point. All right, and now I have this wall that is separating me from the cake. All right, so what would be a good way to search for this cake? Assuming that I am blind, okay, I can't see anything that is more than 1 square away around me. So what would be a good way to go about it? Well, there are a couple of things that you will learn if you're a computer science student, and then I'm just going to remove all of the equations out and then show you visualizations. So one of the ways that you can do this is you search in all directions, okay? So you search equally in all directions, which is what is spreading out at every direction. And then eventually you will come and then meet the cake. All right, and then you will decide, okay, that was the best path to reach the cake. But if you really think about it, this is not the most efficient way, right? Like, because all of these other routes that you're going, apart from going to the right, everything else is unnecessary, right? You're going further and further away from the cake. So I also told you that you are kind of blinded at this point, which means that you can't see anything more than 1 square. So what AI does is it uses a proxy, which means that if it can't see, well, it thinks, is there any other way that I can use any other signal to get to this cake? And one of the things that I would do if I were in the situation is to use the sense of smell, right? And I would kind of take one step in each direction and see if is the smell getting stronger, and if it is getting stronger, then I will explore in that direction, right? And that will kind of move me away from exploring at all of these other parts, because the smell would take a lot, will be a lot fainter in these directions, right? So this is all what something called A star is. It's using other signals to kind of get to the target faster. See how much more faster it is, and you're not exploring a lot in all of the other directions, right? So that's how A star will get you faster. The other one is called breadth first search. There is also something called depth first search. I didn't want to show it here. Not that important, but basically A star is AI. because let's go back to the definition of AI. We said that AI is about making agents act rationally. So it does not have to be about thinking rationally. You don't have to kind of imitate our thinking. It is something that people used to do, but now it's more about acting rationally. So if I give you a cake somewhere here at the right, all I want you to do is to act rationally and then get there as fast as possible. It does not care about the logic that you use to get there. This is A-star. And let's just compare these two images and see how much faster this is. Right? So on the left, you have breadth first search, and on the right, you have A-star. And that's how much faster it is. Now, given all of this, you can probably connect to why I asked about Pac-Man. I'm going to show you a video. So the actual AI in Pac-Man is in the enemies. So it's not the player, but in the enemy. So someone actually answered this in the chat, but let's see how this works. So basically you divide this into a bunch of squares like I showed you in the previous image. All right, and then you have Pac-Man, which can go ahead and eat all of these dots. This is someone else's video, by the way. So the way that the enemies will kind of come towards the player is by using A-star. There are like hundreds of paths that you can take, right? But you want the fastest path for each enemy to come to Pac-Man. And so this is the shortest way without the animations, okay? Remember the animations I showed you in the previous slide? This is without the animations. It will always use A-star and it will show you the fastest path to get there. So the line shows you the fastest or the shortest path to get to Pac-Man. So enemies are, if the enemy was stuck there, it would kind of, it's just computing the fastest path. It's not acting upon it, but in the game, the enemy would also move towards Pac-Man. So that's how AI is involved. So I'll show you a little bit more and then we'll stop. See how this is working now. So basically the line is showing you the shortest path and the enemy is moving in real time along with the player. So also think about if all the enemies had the same speed and were all using A-star and they all started out at the same position, what would happen? So that is a problem that you will see in the next few seconds. So here is where it happens. Did you see that? So basically the orange and the red enemies, right? At some point they will coincide and become one. And since they're both using the same algorithm, they will be stuck together forever, right? Which means like effectively there are only 3 enemies because one is behind the other. So you only have to avoid 3 enemies now. So to avoid this, there are some sort of variables that are used inside Pac-Man. But we will avoid all of that. So now that you know Pac-Man, think of where Pac-Man would be used in real life today. And one of the things that you can almost directly translate it to is to Google Maps, something that you would use probably every day if it were not for lockdown. And then this is exactly the same thing. You have nodes and you have edges, which is like in a grid, and then it's computing the best possible way for you to get from point A to point B. So that's how AI is being used in stuff. And remember, in Pac-Man, we were using A star. A star does not require any training. It's just based on that heuristic thing. But remember the analogy about the smell, and that's how that's functional. If you would love to learn more about things that are related to AI, and the AI is there in a lot of games. If you are into games, definitely check this channel out. It's called AI and Games. It's a really good channel. It talks about AI, not just Pac-Man, but also about some of the latest games. So this is AI of Alien Isolation. Alien Isolation is a game that came out a few years ago, but it's also using pretty standard stuff. So there's something called behavior trees. If you kind of look into it, that's how enemies react. So, if you've ever played a game and then you were sneaking around an enemy and then suddenly you make a sound, you will draw their attention and they will come towards you. That's behavior trees, how they're supposed to behave in various situations. So that's about AI, and so let's recap. AI is the broad, all-encompassing superset of this field, and you don't always need a lot of data for training AI systems. So we'll now move into machine learning. So this is where a machine learning falls in. So inside artificial intelligence, there's this subset called machine learning. And machine learning algorithms learn patterns from examples, which means that they use data. They really use data. So all of them require data, and then they make a prediction based on it. Right? Also, people think that if I write something with machine learning, that will cook food for me and then cure diseases and all of that. That's not true. Typically, they do only one thing well. Okay, and so for example, classification, which we will get into in the next few slides. Classification is when you're given something and then you're supposed to classify it into group A or group B, or class A or class B, right? You can because it will do only classification. You cannot use it to do other stuff, which is like, for example, regression or predicting how much money you will make tomorrow. But it can do classification, and depending on the data that you feed it, it can classify whether a particular object is a fruit or a vegetable, or if a patient is cancerous or he does not have cancer, and things like that. So the data that you feed into machines, machine learning algorithms, becomes really important. All right, so I'm going to show you a little bit of an example we're going to try to build our first model, okay? And if you guys are on your laptops, I want you to try it with me. I will show you one round of how this goes, and then you can open it up and try it out yourself a little later. So this is the URL. So I will put this into the chat screen in just one moment. All right, so this is something called Teachable Machine Learning. It's from Google. And what I am going to do is to figure out if we can train a machine learning model. So this is what I talked about. This is classification. So the moment I click new project, it asks me, hey, do you want an image project, an audio project, or a post project? I'm going to click on image project for now. And so I have two different objects with me. So I have this water bottle that I use to stay hydrated, and I have this pair of scissors. And then what I'm trying to do is I will be building a machine learning model to classify what kind of object I'm showing to the camera. Okay, so I'm going to show this object first to the camera, and then, oops, that wasn't closed. It's going to say, oh, it's a water bottle, and then I'm going to show you the scissors, and then the model is going to say that this is a pair of scissors. Before I begin, I know I have covered a lot of things. Do you guys have questions? That means the sensor input must be kept to identify the man if 3 algorithm is used. I actually did not understand this question, Yasir. Do you want to unmute yourself and then ask this question, or you can explain this out? Oh, I'm in Pac-Man 3. It means the sensor input must be kept to identify Pac-Man. So no, actually you don't need a sensor input. The game already has the X and Y coordinates of Pac-Man, right? So that's how That's how it's kind of recognizing, okay, I have to move closer. So remember the analogy with the cake and the smell. So instead of the smell, it kind of gives a signal. You guys can learn more about it. Just Google for AI in Pac-Man. Feedback link. I'm not sure what feedback link is.
So it's the link which we given at the end of the session. So
All right.
we are having session till 6:30. That's fine.
Okay. All right.
Okay.
Which is a good website to take a full course on AI. I will reply to that towards the end of my session. DFS pattern recognition. Okay. So all right. All right. So I'm just going to start training this model. Okay. So first, I'm going to rename this. I'm going to call this water bottle. And this one I'm going to call scissors. Correct. So now we're ready. So I'll click on, so either you can upload images for training or use your webcam. So I'm going to click on webcam and you can see me here. So I'm going to hold this water bottle up and this button here, right, hold to record. I can't just click on it. I have to hold it down. So I'm going to do that now. I'm also going to rotate this water bottle a little bit. All right, so now what happens is it has about 117 different image samples, right? Which means that there's 117 photos of my water bottle here. And I think that's pretty fair, that's good enough. So now we'll take photos of scissors. All right, so I'm gonna keep it up here and hold. I'm also going to rotate this a little bit so the model gets all sorts of signals. All right, so we have about 119 samples here. You don't have to have equal number of samples. Just make sure that you have at least 60 to 80, and then that should be fine. All right. So now let me click on train model, and a bunch of things happen when you click on train model. First of all, this model is being trained inside your browser, so you have to keep this tab open. All right, so they will tell you that, and also it's giving me some time and some other details. So 5 out of 50. So we will get back to what this 50 is. So just for starters, this is epoch, and we will learn what epoch is. So I have to, looks like I have to wait for this to complete, right? 30 out of 50. So we'll just pause, and this is what people talk about when they're training a model. So you have to give it some time to learn. All right, so now we're good. So at the bottom, right, you have two different things. It's saying water bottle and scissors. Right now, it thinks that I have scissors in the picture, probably because of my hand. So now I'm going to bring in the water bottle and see what happens. So it's, you see that? Sorry. So it's predicting that I have a water bottle up here. So if I give it some sort of weird angle, right, I have never held this bottle in this position in the data set, right? It's like upturned, and then it's
Yes, sir, you're muted.
what happened? Someone else muted me.
Yes, that's
All right, no problem.
technical glitch. Okay, fine.
No problem. So look at this. So I have never held this water bottle in this position, right, before, but it's still predicting that this is a water bottle. So that's the magic of machine learning. That's how easily you can do machine learning. So let's bring in the scissors. Now it's 100% scissors. Right. So I'm going to turn it upside down, rotate it, all of that. So it's that simple, really. So all I did was collect a few samples of images and then did something called training. We will get to know what training is, and then it's kind of able to predict all of this. So let's do that one more time. So I'm just going to refresh this, and I will give you guys the link. So let's do this again, but this time I'm not going to use any objects, so this might not work perfectly. But all I'm going to do is I'm going to, you know what, get creative. Probably I'm going to control a video game with this because we've been talking a lot of games. So let's say I'm playing something like a Street Fighter game where you have to fight opponents. So I'm going to have punch here as in one of my classes, and block here as one of my other actions. Okay. And now, as before, I'm going to use my webcam. And instead of having any other objects, what I'm going to do is I'm going to put my hand in these positions. Okay. So I will also move my hand to and fro and then change the angles a little bit so the machine, the model gets to see all of that. All right, let's get started. That's about 107 images there. All right, let's try block. In block, I will probably use something like this. Okay. And then I will leave it at that. So now there are no other objects, it's just me. The model has to learn from the shapes of the front of my hand and my forearm to actually figure out what I'm doing, right? And this is what we're going to do. And again, I'm just going to click the train button. Again, you guys can try this in the background if you have some objects, or if you want to try it out just like I did now. Right halfway there. Okay, so even without me punching, it thinks that I am punching. Right, let's try block. So this is my other hand. All right, so I'm going to change my hand, and then it's still figuring out if it is punching out. What if I put a punch and a block? So these are the things that you can try out. So also notice what happens if I'm punching and then I move my hand out of the picture, or change what. So this square is all the machine sees, right? And the moment that I move away, then you can't see it anymore. So it kind of makes a decision based on what is available. Also think about what happens if a machine learning model thinks that I am about to punch. I talked an example about video games, right? If you connect this to a video game, and then if you kind of connect this model and I do this and then it does a punch, I do this and it does a block. Also think about how it can be used against us, for example. All right, so think about the moment that I'm about to do something like this. If I'm dealing with a robot cop from the future, or a robot police, and it thinks that I'm about to hit it, and then it kind of shoots me before I do it. In reality, I was probably not going to hit it. I was going to just threaten it, right? So things like this, you think it is fun, but also it could have really good, really impactful consequences. So when you're dealing with projects, I want you guys to think about where it can be used for good as well as for bad. A lot of discussion around AI is based on ethics right now, because there are a lot of problems that are caused by imbalanced data classes and things like that. So we might not get into it later, but just keep this in mind whenever you're developing. Also, so that's the first thing. So you guys saw how easy that was, right? Do you think it's difficult? Do you think it's something that we can do? Try it out. Definitely try it out. There's no code at all. It's just like it's one of the simplest things that happens on. Okay. What's the training part? Does it happen at the client side? Yes, it happens at the client side. It happens inside my browser. And then I'll show you a little bit more on what it is. All right, let's go back. Bunch of other things to do. So Oh man, we've bypassed our first hour. Thank you for sticking with me, by the way. That's one. So there's something we talked about a model, but I did not really explain what it is. So basically, a data and an algorithm together with some training that is stuck together with some training gives you something called a model. Okay, and here in our previous example, all of the pictures that I took was the data, and the algorithm was the deep learning algorithm. Let's not get into what it is right now, but together what it built at the end, the last part, which was taking images and deciding what action I was doing, that's the model. Right. So basically, this is all what we did. We collected some examples, which is our data, and we do something called training, and then we test our model out. All right, so that's machine learning. We will come back to this in a little while, but let me also show you what deep learning is. So deep learning is something that is within machine learning. So it's kind of the deeply nested thing. So you have all of AI, then you have machine learning, and inside machine learning, you have a subset called deep learning. And deep learning is one of the biggest things that has happened. It's why we have another AI revolution right now, all the way from self-driving cars to predicting age, and then creating all of these realistic photos to translation. All of that is powered by deep learning. And basically, it works like this. There is something called a neural network. It's called a deep neural network. There is a lot of jargon around this that I don't want to get into today, but all you have to know is that if you give it an input, a photo of a dog or a cat, it will pass through multiple layers, and each layer is some sort of computation that is happening. Okay, and in the end, the last layer will tell you if it is a dog or a cat. So this is a classification example, just like the one that I showed you with teachable machine learning, and it's doing something basic, and then it's using a deep neural network. So that's about it. Again, this part is where you have your deep neural network coming in. So I'm going to strip a lot of things away and then kind of make it simple for you. So on the right, you have the neural network, the deep neural network, right? So this purple structure, I'm just showing you an even more complicated version. So that's neural network, and on the left side, I want to represent this whole network with a Pokemon. Okay, and basically that will simplify a lot of things for us. So I won't have to talk about the math or the structure of the neural network, but it will help us at least get to know what a neural network is and what it does. So basically, I have pictures of cats and dogs, let's see, or water bottle and scissors, whatever data that you have. And what you want to do is, during training, you want your algorithm to actually, your model to actually see both of these data sets, right? All of the data in your category, so both cats as well as dogs. And finally, when we show it a new image, which is called prediction, that it has never seen before, it has to correctly predict the label. Right, so that is the simplest example. So once again, let's go through that. So neural network is this huge structure that we don't know much about yet, and we're going to simplify it by replacing that with Pokemon, and then we're going to have a data set which is a labeled collection of images. So you can see that all the cats are in one folder and all the dogs are in another folder, right? And then you have your deep neural network that sees both of these deep classes. And when finally we show it something that was never in this cat's data set before, it has to predict correctly that this is a cat. Right? So the first thing, so imagine that you have 100 different labeled images. The first thing that we do is to split it into a training data set, a validation data set, and a test data set. All right. So we will learn about why we want to do this. Bear with me. So, but basically, you're splitting it into something like an 80-10-10 ratio. Okay. So training data set is the only part of the data set that the model sees during training. So remember when I press that train button, so in that instance, I will show it only 80 images. So for example, if I had 50 cats and 50 dogs, I will only show 40 cats during training and 40 dogs during training. All right, so now the model sees both the images as well as their label. So I will show it an image and say that, okay, this is a cat. I will show it a dog and say this is a dog. And then I'll do that for all of the 40 cats and 40 dogs, okay? Then after each epoch, what happens is the model tries to predict the label. So once I show it all the 80 images, 40 cats and 40 dogs, then I will ask it to predict it for the 10 cats and 10 images that it has not seen before, okay? And then I kind of measure the accuracy. If it guesses 6 out of 10 images, I would say the accuracy is 60%, okay? And you remember the word epoch. So epoch is completed when the model completes one pass over the training data, which means that 40 cats and 40 images, total of 80. And then you will also test it with the validation data set, which is about the 10 images, right? So after passing it through the 80 images, pass it through the 10 images in the validation set. And if it says 6 out of 10, you say that your validation accuracy is 60%. All right. Now we don't know why this test data set is used yet. We will come to it. But this is one of this is a screenshot from a real model being trained. So this is from Keras. Keras is a machine learning. It's a deep learning library that is built on top of TensorFlow. And this is what it does. So the first epoch, so it's training for 10 epochs. It has 2072 images, okay? And it took 16 seconds to go through those images. Don't worry about the loss. Accuracy was 34%, and the validation accuracy was also 34%. This means that if you showed it like maybe 100 images, it got 34 of them correct. The rest were all wrong, right? And that's okay. So this is the first epoch. Probably down the line, if you reach 5 out of 10, 6 out of 10, and until the very last epoch, you might have better accuracy. All right. So here's a question for you guys. So let's say that I did some training. Okay. I did some training, and I have my training accuracy is 98%. Training accuracy, by the way, is that if I showed it 80 images, right, and I showed it with the label, right, and you show the same image again, and then ask it, hey, what is this image? It has to correctly say that this is a cat or a dog. Okay? So it's like asking it questions that it has seen before, just to make sure that it knows the things that we have shown it. So it's not very difficult. Think of it like you writing an exam. Okay, so instead of this Pokemon, there is you, and you are going through previous year's question papers, right? 80 of them. Now, if you have seen all 80 of them, and somebody comes and shows you some random example from the things that you have seen before, and then you were able to correctly answer all of them, your training accuracy is 100%, right? If you made some mistakes, you'll figure out how many were correct out of how many were you shown, and that's your training accuracy. So validation accuracy is, there are some questions in the previous year's question papers that you have not, that the other person did not show you, okay? All right, but you still got to see a lot of other questions. And then once you finished learning all of this, the other person shows you, asks you 10 questions that you have not seen before, and then asks you, what are the answers to these. If you answer that, all of them correctly, your validation accuracy is also 100%. Very, very similar to how we learn stuff. And so here you go. So the question is this: so I have 3 different models, okay, 3 different dragons. So which means that, remember that a neural network, a bunch of things inside the neural network are different. So so let's say for the first neural network, your training accuracy was 98%, okay, and your validation accuracy was 94%. All right. For the second model, the training accuracy was 96%, which is a little bit less than the training accuracy you had for the first model. But the validation accuracy was also 96%, which is more than the previous one. So one is a little bit less, training accuracy is a little bit less, but validation accuracy is a little bit more. And in the third, training accuracy is almost 99%, okay, which is the highest of all three, right? And the validation accuracy is only 87, which is the lowest of all three, okay? So here's the question. If you have these three different models, which one would you choose to put into production, or put in your app or whatever? Which one would you use to make predictions? Is it the first one, the second one, or the third one? So put your answers in the chat. I'll keep this screen open for a little bit more time so that you guys can think about it. So again, the first one had the highest, has a really good training accuracy and a decent validation accuracy. Okay. The second one has lesser training accuracy but higher validation accuracy. And the third one has the highest training accuracy and the lowest validation accuracy. The question is, which one will you use? I love this crowd. I've never had these many answers coming in from the students. And all 175 of you are still here. Okay, Michelle is very confident that this is true. All right, so the thing is, what is tripping you guys up? So why can you not make a decision on this immediately? It's not a simple problem, I'll give you that. And the problem is we don't have enough things to compare. So we are not comparing against the standard, we're comparing against two different values, and that's always, it's not something that we can do all the time. So if it was just one value that you're comparing, then that will be okay, right? It's easy to decide because you can choose whichever model performed the highest on that task. So this is where that last bit comes in. So here you cannot make a decision. That's the real answer. There is not enough information to make a decision. So if you were to keep that test set, remember that this is 80, this is 10, and this is also 10. If you keep this last 10, you never show it to any model, okay? And then you reach a point where you have three different models and you want to pick the best out of them, you will show all three models that test set. So you have the labels for this also, but you will only show the images to them and then ask them to kind of make predictions, okay? And then we will come back with the final answer. So you will only show it once, okay? And then you can't go back and train the model again. You will only show it once to every model, and the one that picks the highest, one that scores the highest is the one that you will use. Okay, does that make sense? So now you don't have to compare the training and validation accuracy. You compare it against a new set of 10 questions which you have never shown any of these models before, and that's how you pick out the best model. Does that make sense? You guys feel free to ask your questions also. Yes, I can explain once more. All right, so let's go back to the very beginning. So you remember we have 100 labeled images, all right, and 50 of them are cats and 50 of them are dogs. So you split the data into 80, 10, 10. 80 means 40 of them are cats and 40 of them are dogs. And then you have another 10 that you will not show any model yet. And this last one is the test set. Keep your eyes on this and see what happens, okay? So first, during training, you will only show the 80 images to your model. So it gets to see all the 80 images and their labels. So I show it a cat and say that this is a cat. I show it a dog and say that this is a dog. And we do that for all of the 80 images. Second part is I show it 10 different images, okay, that it has not seen before. So that is not in the training set. And I do that, and then I ask it, hey, is this a cat or a dog? But I will not show it the label, okay? I ask it, hey, is this a cat or a dog? And then it gives me some value, and using that, I will predict the validation accuracy, okay? So if it answers 5 out of 10 questions correctly, I will say that the accuracy is 50%. And I do that, and then now I have the training accuracy as well as the validation accuracy, okay? Notice we have not used the test set yet, okay? And this is an epoch, this one complete process of showing 80 images in the training set once and the validation set once. So those two things together are forming one epoch, okay? And if you've seen the previous example, right, we have seen something like In the Google image, the experiment that I showed you, it's at 50 epochs, right? So that is what it means. So it internally divided the data set into something, and then it had a training set and a validation set, which it did not show you. But it ran it over the training set 50 times and the validation set 50 times together. So one time it runs through the training set and it runs through the validation set, and those two actions together form one epoch, and it did it 50 times. And then it has its final training accuracy as well as the validation accuracy. All right. So our problem was we had the training accuracy and validation accuracy after 5 epochs, just say random. So in the other experiment, it was 50. So in the end of 50 epochs, let's say that your training accuracy was 98%, validation accuracy was 94%, training accuracy was 96%, validation accuracy was 96%, 99, 87. Right? So these are 3 different models. The problem is all of them are kind of juxtaposed, right? You can't decide which one is better. If you look at only the training accuracy, you can say that third one is the best. If you look at only the validation accuracy, you can look at you can say that the second one is the best. So it's hard to compare, which is why we're using that third part, which we never shown any model before, and then we're showing all of these models, those last 10 images. It's like the final exam, okay? In the final exam, you never get to see the questions beforehand, right? And then you're shown a bunch of 10 questions, and then everybody has a score, and the model that scored the highest will be the rank holder or the guy who will be promoted or used in production. Does that make sense? Awesome. Awesome, good. Yes, someone has a doubt. Feel free to unmute yourself and then ask your question. Yes, sir.
Hello, sir. Can you hear me?
Yes, I can. Go ahead, yes, sir.
Sir, what do you mean by validation? I didn't get it, sir. Training means like repeating the steps, right?
So training is a combination of, yes. So in training, you remember this image? Let me show you this. You remember this image, right?
Yes, sir.
So here you're showing both the image and telling the model that this is a cat, okay? So you show it one image and say that this is a cat. You show it another image and then say that this is a dog. So the model knows the picture as well as the label associated with it. Does that make sense? So that is what happens during training. During validation, what happens is that I will have another bunch of images, okay? I'm just going to copy this. Or let's see. With PowerPoint today. Anyway, so I will have a bunch of other cats also. I will have a bunch of other cats also. And what happens is that these cats we will not tell the model if it is a cat or a dog, okay? So for example, let me draw some basic shapes. See that this is a cat. Okay, and this is a dog. Okay, this cat and this dog, I will not show it to the model during training. Okay, it will only get to see all of these 5 cats and these 5 dogs. Okay, during validation, what happens is that I as a person who created this data set, knows that this is a cat, okay? And I will show it just the picture, okay? And the model will have to predict whether this is a cat or a dog. Does that make sense?
Okay, sir. Okay, that's mean validation, right?
That is validation, yes. Okay. So it kind of tells me whether it is a cat or a dog. And if it is correct, I will add a score. If it is wrong, I will say 0. And then I will finally total it up. So I have only one cat and one dog here extra. So after going through all of these 5 images of cats and 5 images of these dogs, I will show this image and also this image. So if the model says this is a cat and it says that this is also a cat, okay, let us compute the validation accuracy. So this one is correct, right? This is actually a cat and the model said it's a cat, okay? But this one is actually a dog, but the dog said that, but the model said it is a cat. So this is wrong and this is true. And we have a total of 2 validation images, out of which 1 was correct, okay? And therefore the accuracy is 1 out of 2, which is 50%. Does that make sense?
Okay, sir. Okay.
All right.
Thank you so much.
No problem. All right. Any other questions, guys? This is the hardest part, okay? We did this without equations. If you guys understand like 80% of it, I'm super happy. Okay, the validation set and the test set, the difference is the test set is only used for comparing different models, okay? You never use the test set for during the training part. It is only when you have something like 3 different models and then you want to compare it. For example, there are different, I talked a little bit about this dragon, these things before, right? So this is a neural network. I'll show you a few more things. So forget this first layer, okay? All of these horizontal, I mean like vertical slices are called layers. And this is the first layer, this is the second layer, this is the third layer, fourth layer. So this one is called the input layer, and then you don't care much about it, okay? It's not really counted. So this is a neural network with 1, 2, 3, 4 different layers, okay? The other colored dragon that you see here, this gray one, let's say that it has another layer also. So this blue is connected to perhaps another orange set of things, and then everything is interlinked. So that is how machine learning models become different. Their structure changes, okay? And then the thing is that you will have different models with different structures. It's a little bit crazy, I know. But if you have different models, it's like having 3 different kids, okay? Somebody is good in science, somebody is good in math, somebody is good in English, and then you ask them, you show them standard question papers and then see which one does better. So all of them have different learning abilities, right? So one person might do better in one thing. So that's how you have all of these different scores, okay? So it is only, so this thing works much like the final exam. So you have 3 different students and then they've been taught on some training set. You only use the test set to compare between 3 different students, okay? So that's why the test set, that's the main difference. So the difference with the validation set is that everybody sees the validation set during their training, okay? Which means that you will go through your training. So each student gets to see all of the previous question papers, but they will also see a bunch of questions that they haven't seen before. That happens during every epoch. So again, an epoch is something like this. You have a training set and a validation step. So those 2 things together form the epoch. So at every epoch, you see both the training set and the validation set, but you never get to see the test set at all during training. It's only when you have 3 different models that you will use the test set. Does that make sense? Awesome. All right. Good. Keep your questions coming. I love your questions. You guys are also very, very interactive. To be going. All right, I have just about 30-40 minutes. I think there are about 40 different slides also. It's mostly visualizations. But let me also show you certain things. You guys know this, right? So this is a self-driving car from Tesla. Basically, it charts your path using Google Maps, like we mentioned, using A-star, and a little bit more sophisticated than A-star, but that's the basic system. And it starts driving, right? So I wanted to show you how, I wanted you to think about how this is trained. And if you know the story, right, Tesla actually put out all of their cars right from day one with self-driving hardware in them. And then one day they just switched on autopilot. Okay, so that was a software update, and then all cars became self-driving. So I wanted to show you something similar. I wanted to show you something called an evolving self-driving car. So I know we said no programming, but let me show you certain things. So this is an example project. So this is a racetrack. Okay. So on white is a racetrack. It's a closed loop. So what I'm going to do is I'm going to create a bunch of cars. Okay. And then initially they don't know how to drive at all. So they will go ahead and then try something out. They will steer left or steer right, and then they will go crash into the walls. But we are going to give them a score based on how far from the starting point they have come. Alright, so for example, if I only moved 1 meter from the starting point, my score is 1. If I move 10 meters, it's 10. Okay, like that. So the goal is to maximize the score. Okay, and you can maximize. Theoretically, you can get infinite score by just keeping on driving without hitting anything. Okay, if you die, we create a new car instead of the crash car. Okay, this is how it goes. So see, the first generation, a bunch of cars are hitting the walls and all dying. One car somehow got here, and you can also watch the track that it's making. Okay, so currently these lines are really thick because a lot of cars have been going around this part, but eventually I want you to see these lines start getting more and more red, right? Stronger, because more and more cars have passed on. Right, so one car made it back to the loop. Yeah, a lot more cars are going around now, fewer crashes. And over time, you can see this getting thicker, right? Because cars have started learning to drive around this curve. Now it needs to kind of figure out how to drive around this curve also. So more of them are making it. It's trying out all sorts of variations here at this point, right? It's trying to steer straight, it's trying to steer right. A lot of different variations are happening. But here and all, it's pretty standard. It's pretty much figured out that this is the route that it has to take. All right. So this is how neural networks kind of create generations, and then this is the average. So this is the generation. So generation is when a bunch of people have died. It's like a human generation. Like your father is one generation, your father and your mother are one generation, you are the next generation. So when one generation dies, you start the next generation. So and now over time you can see this average distance increasing, right? And the lines have become really thin. There are no crashes. It makes a pop sound when it crashes. I don't know if you guys can hear it, but that's happening rarely now. All right, so I'll put in the link. You guys give it a shot. This is the best library for machine learning. There is no best library for machine learning, but we will talk about a couple. If you're using Python, one of the good ones is scikit-learn, sklearn. So sklearn. That's one really good library. People use TensorFlow and PyTorch and things like that for deep learning, but I suggest you stay away from it unless you get the basics right with scikit-learn. And it's only about a couple of lines, maybe 2 lines. You can train a machine learning model. It's model.fit. That's it. So that's really simple. MATLAB, I'm not sure. I have not been a very big fan of MATLAB, but they do have some sort of capability for all of them. Okay. Google Colab is not really a library. It's more of it's like a tool in which you can program, right? So it's not a library at all. Is AI better than ML? Yeah, depends on what you're doing, right? For example, if you want to do stuff without doing a lot of training, is there an AI solution for it? Maybe that's a better choice. Maybe you don't even need AI. You can probably get some things done with if-then-else statements, right? Will artificial intelligence ever have emotions or feeling? There are a good amount of people who are working on this. So check out a robot called Sophia, SOFIA, I think. It's a guy who has been developing something called OpenCog. And OpenGog is very mappy, but so this company that is making Sophia is called Hanson Robotics. And Hanson Robotics believes that if you blend emotions with machines, then they can be a lot more. I mean, like, they can be a lot more useful. They will think from the human perspective, but also, yes, AI is dangerous if you put it in different places. For example, a lot of cases around AI have been that people who really need healthcare and insurance, a lot of AI algorithms are making these decisions. And certain times, certain AI algorithms have denied people who need care the most because it saw them as being very, very expensive. So in the insurance industry, if you have a machine learning model that kind of optimizes for the company, right? It decides who to give insurance money to. If it sees that you have a very terrible disease, it's going to deny your claims and do everything that it can to kind of shut you down, right? Because you're expensive. So in that case, yes, AI is certainly. What makes machine learning different from deep learning? Machine learning is I told you it's a broader term, right? And that is one difference. Deep learning always involves neural networks, all right? Like always. So neural networks is a specific structure or an architecture for machine learning. So that is what makes it different. How the robot like Sophia can express emotions. Someone told this before, but check out sentiment analysis. I'll give you a starting point. It won't give you all the answers, but it'll give you. Can you explain short definition for it? So machine learning, we talked about this, right? So machine learning is learning patterns from data. So it definitely needs data. And there are formal definitions of machine learning. So I don't want to give you that now. So basically, it relies on experience, a metric, and task. So model. So the definition kind of goes like this: a model is set to learn from experience E. If its performance P over a metric M improves over time, or something like that. And it's a very complex definition. I don't want to give it. So basically, it learns patterns from data. That's what I teach people. All right, moving on. I have half an hour, so I'm going to skip over deep traffic. So again, so these are the three things that we learned: AI, machine learning, and deep learning. Good, you guys have timed this question right. So again, artificial intelligence is the broad spectrum. Machine learning is a subset, and deep learning is an even small subset that uses neural networks specifically. Okay. Neural network is that layered thing that I showed you. So artificial intelligence generally does not need data. The orange part does not need data, but if it falls within the yellow part, definitely needs data. All right. So I'm going to introduce you to a few things that you might hear. It's called supervised learning, unsupervised learning, and reinforcement learning. All fun examples, and we will get started. Okay. So inside supervised learning means that your data is always labeled. You remember that example with the cats and the dogs? I had labels for cats. All the cats were grouped together, put in a folder called cats. And all the dogs were grouped together and put in a folder called dogs. Okay? So that is what is meant by label data. For every image, you have a label associated with it. Okay. And I'm going to show you one example. It's called a decision tree. Okay? We're going to go to something called unsupervised learning, where the data is unlabeled, which means that you have an image, but you don't have a label for it. Your task is to probably find a similar image and things like that. Right? In Google image search, you probably have done this. You have searched by image and then you put in an image, and then Google shows you similar images. Right? And the last part is called reinforcement learning. It's learning from the environment, and I'll show you what that is. So let's start with supervised learning. So something simple called decision trees. Okay, you might have questions here. It might get a little bit complicated. I'm trying to cram 2 different days of my workshop into one, so that's why there's a lot of questions also. But you guys are keeping up really well. All right. So imagine this: you have 5 different fruits in a fruit basket. Okay. So I have 2 different grapes. Okay, these are grapes at the right. Excuse my diagrams. A lemon, okay, and 2 different apples. Okay, one of them is green and one of them is yellow. Right, so roughly I'm also putting a size to it. Okay, so the apples are the biggest, right? So apples are size 3 and one of them is green and one of them is yellow. Okay, the grapes are both red, right? Both of them are red and their size is 1, the smallest. And the lemon is kind of in between. I mean, it's a size 3, it's almost the same as the apple and its color is yellow. Okay, so this is what you have. Now the task is I want you to figure out the label, okay, given the color and the size. Okay, so if someone says the color is this and the size is this, I want you to kind of come up with a way to say that what would be that label. Okay, so in machine learning terms, we call these two things features. These are the inputs to the machine learning model. So someone will tell you the color and the size, and then you have to predict the label, which is the fruit. Okay, so can you guys try to answer this question? What is a good rule to identify grapes from the features? So can you say color is something and then predict that this is a grape, or size is something, or a combination of those things? I'm going to keep the slide for a little bit longer and then I'm going to switch to the chat. Combination of color and size, size, color. What would you say? The color is dash and the size is dash. I want you to give a clear answer. Red and 1, that's definitely a combination. But also look at this, okay? If it's red, you don't have to check the size, right? Because anything that is red in the basket is definitely a grape. Right? So your answer is right. Red and 1 will definitely give you a grape. But also if you just say anything that is red is a grape, that's also true. You can also say anything that is of size 1, that is also a grape. Right? You don't have to necessarily look at a combination. But that answer is true. Okay, size is equal to 1 or color is equal to red, or you can say size is equal to 1 and color equal to red. Does that make sense? All right. So here's another question. What's a good rule to identify lemon from the features? I'll give you guys some time on this. Ready? Someone said color equals 3. I'm assuming even color is yellow and size is 3. Yasser is saying that we cannot. And Yasser is right, because look at this. So if you were to say that the size is 3, right, you have both apples and lemons. Okay. If you were to say color is yellow, you can see that we have a yellow lemon as well as a yellow apple, right? So if you look at the features, so here look at these two different columns. So yellow and 3, and you have the same thing, yellow and 3, but they have different labels. Okay? So this is where people have a problem with machine learning. They kind of introduce machine learning because of it. So the thing is, this data set is not perfectly separable, okay? Which means that you can, regardless of what rules you write at this point, there is no way to clearly separate out the lemon from the apple. It's kind of confusing. Okay, I think we have one more question. There is no perfect rule. How would you identify apple from the features? If I give you a color and the size, can you say that for definite this is an apple? Is there a way that you can say that definitely an apple, or a combination of color and size? That's true. Actually, there is a way. If someone gives you something, so there might be a kind of confusion with this question. I'm not asking if you can predict all apples, Okay, so I'll give you some more time for this. I'm asking, if I give you a combination, can you say that there is no chance that this is anything else? This is definitely an apple. Can you say that? Yes. Yes, that's true. So if you look at this, if somebody says the color is green and the size is 3, then that is definitely an apple, right? The problem happens when somebody says the color is yellow and the size is 3. So if somebody says the color is green, you can say for sure that this is an apple, right? Only problem is we don't know if somebody says yellow and size is 3, you don't know if it is an apple or a lemon. So this is another rule that we can use to say, okay, this is an apple. Now we're going to put all of these things together. Okay. So this data set is not perfectly separable. So this is what a decision tree does. Okay. All it does is it asks a few questions at every point. So it decides the best question to ask and how to split them. So first, the model will kind of figure out, what are the questions that I can ask. So I have color as well as the size. So I can ask questions based on those. And then it figures out which questions should I ask. So should I ask diameter greater than or equal to 3 first, or should I ask for color equal to yellow first? And depending upon that, so for example, if it asks diameter greater than or equal to 3, if it is no, we know for sure that this is a grape, right? Grape is the only thing that does not have a size of 3. Its size is a 1. So both of the grapes will fall into this category, and all of them are grapes. So you can definitely say that this is 100% grape. Okay. Now what happens if the diameter is greater than or equal to 3? So you have 3 candidates from the entire data set, right? So you have 2 apples and a lemon. Okay. So now you ask the second question. You ask, hey, is the color yellow? And if the color is not yellow, right, which is it was green for this, you will only have 1 candidate here, and then that one is definitely an apple, right? So you can predict with 100% accuracy that this is an apple. Okay, and the last part is confusing. So if the color is yellow and the diameter is greater than 3, you have 2 different candidates. So one of them is apple, one of them is lemon. So you cannot make a fair prediction. So you predict that 50%. It might be an apple or it might be a lemon with equal probability. Okay. So basically that is what happens. So let me walk you through it again. Basically the same things that you guys have been answering for my quiz here. Basically the machine learning model will kind of predict what rules, what questions to ask and in what order to ask them. So first it'll ask them, hey, is diameter greater than or equal to 3? And if it is greater than 3, or you can say diameter less than 3, okay? Or you can say color equal to red, and then that will give you a different tree, but it will also help you predict the same thing. So if you ask color is red, and all of the true ones will go with the grape, and then you can say that this is definitely grape. If it is not, then you can change the order and ask, hey, we've asked the color first. Now you can also ask color is green. So out of the rest of the things, you can say if the color is green or yellow. So if it is green, it is definitely an apple. If it is yellow, you have the same problem. You say 50% apple, 50% lemon. Does that make sense? Is there any rule or formula? Yes. So there are a bunch of things if you want to get into the details. So CART is the type of decision trees that we're using. So CART is classification and regression trees. And there is something called Gini impurity, which we are using to kind of decide what questions to ask and what labels to assign. But you guys don't have to worry about that. You just have to know that, okay, this is all that the machine learning algorithm is using. It's just creating rules just like you would create rules, okay? I'm kind of demystifying what machine learning algorithms are doing internally, so that without all of the fancy words and the math, you can still get to know what it is doing. So it's asking what some of these questions, the order in which they're asking these questions, and also what kind of questions it is asking. So it's a greater than or equal to question, or is it a equality check and things like that. So that's all it's doing. Does that make sense? Awesome. All right. So basically, that's what machine learning models are. This is a supervised example. Why is it called supervised? Can you of you answer me? Why is it called supervised? I'll tell you. You don't have to worry. Supervised is when you have labels. Remember, so for the images we had a folder name like a cat and a dog, and here instead of the folder name we have the label for the fruit. Right? So we know that this is an apple, this is a grape, and this is a lemon. So that's why it's called supervised learning. Just to kind of contrast that, I will show you the next one also. This one is called clustering. Okay, and so the previous one was called decision trees. So this is a decision tree, and I'm going to show you something called clustering. So let's go into clustering. So I'll show you a demo. So clustering is basically kind of grouping close together items together, and you will get a better understanding. All right. So how many groups do you guys see here? Group is a bunch of circles. 3. Yeah. The question is, why did you guys say 3 now? Right, so this is something that you're internally doing, right? Without even, yeah, it is separated. That's right. So how do you figure out if it is separated and then when machines don't have any idea of separation? So I'm going to show you the way that machines will classify or kind of figure out that these are different groups. Okay, so I'm just going to add 3 centroids. So one centroid is here, one centroid is here, one centroid is here. It automatically figured out. So let me restart this, or I will choose Gaussian mixture. Okay, I'm gonna put 1 dot here, okay, and 1 here and 1 here. All right, so these are the 3 centers that I'm starting out with. Okay, watch what happens now. So all the points get assigned to the centroid that is closest to them. Okay, and these are random points, and then I put these dots here. Okay, so now what happens is I will click on update centroids, and what happens is this centroid will change. Okay, it will update to a position that is an average of all of these points. Okay, so it will take the x and y coordinates of all of these points that are falling within this blue region, and it will put the centroid right there. Same thing for red and same thing for green. So in one move, it kind of figured out these things. Right? So now, regardless of how many times I try to change, nothing happens. So let me try this again. So I'm gonna put it like this. Okay. Now what happens is only these 2 points get assigned to the red one. All of these points get assigned to the blue one, and all of these points together get assigned to the green one. Okay. So I'm starting out on updates and centroids. See that changes. So now this red dot is between the 2 dots. Okay, that is what is meant by average. Now you know that the previous bunch of things that were part of the green is now part of the blue. So the next update, blue will change its center. And now I keep doing that. So red is kind of expanding. So red moved in. Now all of these blue points will also turn red. And slowly it is getting in the way. And then finally it kind of settles. Okay, so you can see the problem, right? Even though we kind of intuitively think or we are able to separate these as 3 different points, the model is not able to make it just because it kind of started out wrong. Okay, so let's do that again. So you can do that for any sort of things, right? I'm going to do this again. So also watch what happens. So instead, if I don't put the red here, I put the red here, blue here, and green here, right? If I start it now, what happens is you still figure out 3 different points, right? 3 different centers. But the problem is initially the red points were all labeled here, right? And this was green. Now it kind of switched. So depending upon where you start or where you start with your centroid, it changes the labels for you. And also notice that, remember, I did not ask you, we did not put labels to this, right? We have these, all of them are independent individual circles. All of them are equal in all respects except their position. So there is no label that we can put to them. So we can't say red and green and blue because red and green and blue depend on where you put your centroid, right? But if that was not a problem, that is why you don't have labels to these. So there is no labels. You kind of decide what labels you want to put there. So that's why it's called unsupervised learning. So mostly this is used to figure out things like, what are images that are similar. For example, if I pick this point, right, and I ask you for recommendations, you don't give me recommendations from this group or this group. You find the closest things that are next to it. So for example, if this is a picture, you will pick out the pictures that are closest to this, right? And so that's why it is kind of used. It's used in recommendations a lot, and also for classifying images. For example, certain emails that you get are spam, right? And then spams have a specific pattern. So that's how you kind of group things into spam and then do all sorts of that stuff. All right, group of blogs and all stuff. I hope that made sense a little bit at least. It's different from, I'll also tell you why it's different from the other one, because here you have very clear apple, grape, and lemon. These are the things that you wanted to predict. Here there is no correct answer because it could, all you can do best is that you can figure out that there are 3 different groups, but there is no label for each group. It is not A, B, or C. It is not 1, 2, and 3. It is not news, politics, and sports. It's just 3 different groups. That's the best you can do. All right, I'll just show you some more fun things. Now we've gone into a little bit of depth. I'll show you what reinforcement learning is. So here is a model that was kind of learning to play video games. This was in the news a bunch of years ago. So this is from a company called DeepMind, which got acquired by Google. So now this is a game that you might be familiar with, and the game. So the machine learning system was not told what to do. Okay, so it does not know what to do. It does not know the controls. It's just trying out random things. Okay, so it's just moving the paddle left and right. It has not even figured out that it has to hit the ball. After a while, that changes. It kind of understands that if it does not hit the ball, then the game will end. So after about 2 hours of training, starting to learn to play the game. So now it's doing pretty well. And researchers thought this was it. Okay, they thought now the game has finished. There's nothing more to learn. So another 2 hours into training, the model learns to do this. So it's digging a hole in the left side, right? Because it knows that if it finishes digging the hole, it can put the ball in, and then the ball will basically automatically be stuck there, and it will kind of do all of those things for itself. So let's see that again. So it's kind of strategizing what to do. So it's digging a hole, put the ball in there, and the ball automatically bounces there and then kind of scores things automatically. So it's minimizing work. So I'll show you one more example. This is called reinforcement learning. So you guys remember the robot example? So something very similar. This is an DeepMind's AI. It's trying to learn to walk. So there are all sorts of obstacles. It's learning to jump and do all sorts of things, right? So nobody's programming it to do these things. It's kind of learning with thousands of iterations. So you do this over and over until it succeeds. Do you know? Do you guys know why the arms are flailing around? Why is it not you know running like us? The reason is probably the position of the hands do not matter that much. So regardless of how many times the model has kind of uh, did this, it found that there was no use in having hands. You're as good without hands or in hands any position. It does not change the way that you run. All right, so that's another example. I'm not sure if I want to show you this. Let's do it anyway. So this is an example of hide and seek. This is also reinforcement learning. Reinforcement learnings are always there in game environments. Okay, so this is OpenAI's hide and seek system. So they got a bunch of blue characters to hide, and then the red ones will go seek them.
This is a hard world for a hider who has only learned to flee. However, after training in millions
So
of
they
rounds
started.
of hide and seek,
They have movable boxes and all, right? So what happened is that the blue ones decided to actually, before the game started, they would block the entrance and then lock the blocks in place. So even if there were multiple entrances, they would cooperate, and then one would put one block here, the other would put the other block here, and then they would lock it. And so the seekers would never get inside that entrance.
After many generations of failing to break into the shelter, the seekers
And so they gave it a ramp, so the seekers will start, using the ramp to come and seek them. So later, what happened was that the hiders will take away the ramp first, and then they will block the entrance. So the seekers cannot use the ramp at all. So there's no other way that they can get in.
We've also put these agents into a more open-ended environment, randomizing the objects, team sizes.
So they did it with a bunch of different things. And what happened was that if it was all movable, these guys figured out a way to actually build an enclosure and then lock it in place so that the seekers will not be able to access them.
The hiders move them to the edge of the play area and lock them in place.
So that was cool. So this is all reinforcement learning that your characters learn from the environment. I'll also show you one more example, and then we will stop. So this is Snake. I'm not sure if you guys are aware of this game. So used to be there in the previous generation of Nokia phones. So basically, the Snake game is when you'll have to eat food particles and then you grow bigger. So just like you remember the car example that we showed, this is very similar to that. So basically, you're going to create generations of snakes. So this is also another neural network. We talked a little bit about this. There are 3 different layers here. So this is the first generation, kind of got stuck. Then it started learning. So on the top left, you can see the generation. So this is generation 2. Some of them figure out that they have to eat food and they should not touch the walls. This is generation 5. So by this generation, they're kind of using a similar strategy. They're going to the top and then coming down. So do you think that is the safest way to go about it? Then it keeps on improving. Okay. So that's it about reinforcement learning. That's all the examples that I wanted to show you. We are just in time. So Python is the easiest language if you want to get started in machine learning. So this is the book that I would recommend if you have no clue what Python is and you have not programmed, because this is the place that I have started learning. Yes, it's just like it's Pac-Man without enemies. You just have food particles and you're not supposed to hit the walls. Correct. So so Python is the one. So you can use MATLAB, you can use R, you can use Rust, you can use whatever you want. But if you have never programmed before, if you think programming is complicated, I urge you to try out Python. It's the easiest way to get started. I also recommend one course. So this is a course by Sebastian Thurn, and he's the guy who kind of started the whole competition with self-driving cars. So he started it way before Tesla, but then I think Tesla overtook them. It's a very beginner-friendly course. There's lots of coding. It assumes you know very little Python. It will teach you a little bit of Python also along the way. Those are two things that I highly recommend, and that's it. So I hope this has been useful. I know we did not do a lot of coding at all. This was a really quick intro. I hope you guys have some basic understanding of AI and machine learning and deep learning. Also, some intuition about what some of these things do. It's not that mysterious. It's not that you will never be able to learn it. It does not require you to have a high-level understanding of math, unless you are planning to invent your own machine learning algorithms. What basically happens in the industry is that people have figured out all of these algorithms. We just decide to train them and then use them and deploy them. So I hope you guys will try out some of the things that we learned today. Give it a shot. Copy all of the links now. I think whenever we stop the meeting, you will lose all of these links. And that's about it. So I'll now give you guys some time for Q&A. Please feel free to unmute yourself and ask questions, or you can put it in the chat. What all subjects do we need to study in AI? Do you want what all subjects do you need to study before going into AI? Basically, not a lot. It's best that you guys just go discover AI and then follow what interests you. That's what I did. So I always hated math, and part of that is because of the way that I was taught math. And then there are a lot more accessible and interesting ways of learning math today. So there's this guy on YouTube called 3 Blue 1 Brown. Take a look at his videos. It's a really good channel. It explains linear algebra and a lot of things. How much time does it take to master this? If you want to master it, it'll take you a lifetime. I don't think that I am very good at it. But if you want to be reasonably good at it, probably about a couple of years of work. Try to get involved with the industry. Try to get internships. Try to do projects. Don't just watch videos and then think that you understand it. It doesn't happen that way. You have to try out a bunch of things. In machine learning, a lot of people don't know what output you will get without trying it out. So it's a lot of experimentation. People haven't figured out a very specific way to get the right answers. On reinforcement. I'm not the best guy on reinforcement learning, but I know a little bit, maybe sometime in the future. I was thinking this would be my last webinar on AI. So I was planning to take the rest of this year off to kind of learn a little bit more. It's a good platform after engineering, definitely. So I landed up in AI by accident. I kind of I was doing my electrical engineering, and finally after completing my final year, I learned, okay, that this is not the place that I want to be. And I was good with programming. I was building websites, a lot of other things. And by some coincidence and serendipity, I kind of ended up in AI, and that's when I kind of decided. One needs to go for a job on AI. What topics need to be done? Basic things. Just start out with linear regression and classification, but understand them well. Okay, so understand them really well. Figure out how you can do simple things really well. Okay, the thing about new people I find is that they want to do the most complicated part of the equation, like the generating the faces, realistic faces, right? That's super complicated and it takes a ton of compute and effort. So basic programming, get it solid. Understand linear regression and classification. If you know those things, you're probably in, because all we want to know is that you have the basics right, because we don't expect people who just graduated to know a lot about AI. Okay, you might have read something, but if you have the basics, you really want that. Is math a really important section to be covered? My journey has been different. So I tried out a bunch of things. You can do a lot of machine learning without touching the math, right? But it gets interesting when you start discovering the underlying math. And that's how I went. Thank you so much, Alvin. Announced FP announced that will shut down one of its AI research because it's developed. That was wrong. You just Google this, okay? There is a lot of myth around. So let's try this. So Facebook AI language myth. The truth behind, just figure out this thing, okay? There are certain things that are just hype. All of these reporters just want to write something and then they kind of write their own understanding of it. But this is basically false. There is an explanation given by the Facebook researchers, and that's probably covered in this article also. So I'll just put the link here. What should I choose next after BTech and CS? After BTech and CS, I don't know. I haven't done anything apart from BTech. So I'm not the best person. Thing is, if you want to be in AI, just do some oops. If you want to be in AI, just build some projects. Have a GitHub repository if you can. Make sure that you populate it with something interesting. Do a few courses. Start with the one that I showed you and then proceed to what you find is most interesting. So now the problem is you have to stay focused. Okay, if you pick one course, I want you to finish that course regardless of what that course is. Or what I see in people are that they're picking up 20 different courses and then doing the first lesson and then moving off to another course. Let's say their 21st course, and then so that's why I don't recommend more than one course. Just do that one course that I showed you, and then that will be a good place for you to get started. There are other resources that people say are very brilliant, but the reason that I sent you this one thing is because it's simple and it's accessible to everybody. It's very, very simple. There is not a lot of math and stuff. Are you in GitHub? Yes, I am. So basically anywhere you go, and this is my handle. So if you search for it, this will be the first thing that you will find. More than machine learning here. I am into a lot of different things. So this is the link. All right, guys, please give us feedback. Let me know what things to improve. I know we rushed through a bunch of things, but I tried to show you a lot of visualizations. If any of that was not clear, let me know. This is my email address. And feel free to contact me in case you guys need help. So with that, I think I will wind up. I've gone 10 minutes overboard. So Jashan, back to you.
Thank you, Nia sir, for joining with us today.
Thank you so much for having me. Bye-bye.